Okay. We're going to take a look at some styles of factoring. So we have this quadratic. It says y is equal to 6x squared minus x minus 1. Okay. One of the first things we usually look at is, can I find a common factor here? And in many cases we can common factor and probably get our a value, which if I write the standard form, the general standard form of a quadratic, it kind of looks like this. Squeeze it in above here. Bx plus c. And sometimes when you common factor out, you might be able to get an a value of 1, and we can use like a very quick product and sum, which you've done before. This one isn't so nice. There's not a 6 in all three of the terms, so I can't common factor out my 6. So there's a couple different styles. One is called decomposition. We'll just go through two of them. And decomposition actually uses the product and sum to start. So you're actually looking for two numbers that multiply to the a value times the c value. Okay? So in our case, that's two numbers that multiply to 6 times negative 1, which actually gives us negative 6. So two numbers that multiply to negative 6. And then same idea for the middle term. We're looking for two numbers that add to whatever the b value is. And in our case, the b value happens to be negative x. Do you know what number that could be if it's negative x?
Negative 1.
Very good. So we have negative 1.
Does the same two numbers that you multiply to get to negative 6 have to be the ones that you add to get to negative 1?
No, they won't always be the case, actually. So we'll take a look at this example. This is a perfect example for the question you just asked. Because we have 1 and negative 6, that's what we multiplied by, so are those going to be the terms? We're going to try to test that out right now. So let's write this up in red. So I'm going to look for two numbers to start. So we know we need two numbers that multiply to negative 6. What we'll do is we'll look for factors. We'll look for a pair of factors, because there are so many different numbers that can add to negative 1, so we'll just think of factors of 6. In the very first one we had, we'll go with 6 and 1. 6 times 1 gives us 6. So if I make one of these negative, for instance the 1, that gives me negative 6. What's 6 plus negative 1? That doesn't work. That's actually 5. What if we put the negative on the 6 instead? So we try both variations of it, okay? Negative 6 times 1 gives me negative 6. That works out. Negative 6 plus 1 is negative 5. So that doesn't work. So those aren't a term. So we know we've done 1 and 6. Those are no good. Can you think of any other factors of 6?
2 and 3.
2 and 3. Let's try those. 2 times 3. Well, 1 will have to be negative. Any guesses at which one might be negative? Doesn't matter. We'll try both. Okay.
The 2.
Sure, let's try the 2. Negative 2 times 3 gives us negative 6. That works. Negative 2 plus 3. If you get your calculator out, you're going to find that that's actually going to be positive 1. So it doesn't quite work because we're looking for negative 1. We'll switch our way around again. 2 times negative 3 still gives us negative 6. And 2 plus negative 3, that gives us our negative 1. So there we go. We have got our two terms. 2 and negative 3. But unlike in the original product and some where we just put them directly into a set of brackets, we can't quite do that here, just because our a value is not 1. So instead what we do is we're taking the original equation. I keep the first term the same, 6x squared, and the last term is still negative 1. But what we're doing is, and this is why they call it decomposition, we decompose the b value. We decompose it into these two numbers. One of them being...
Do they do 2x and 3x?
Yes, so positive 2x, and we have to be aware that we did negative 3, so negative 3x. So, and the reason this works is because if we take 2x minus 3x, we get negative 1x. That's exactly what the b is. So all we've done is broken it into two numbers instead of the original one, which looks like it's making it more complicated, but it's part of an algorithm or a process to get to the factored form.
Yeah.
Once we've done that, we're going to start looking for common factors between pairs. So I'm going to take the first two terms, and I'm going to take the second two terms, and I need to find a common factor, which is another style of factoring. I need to look for numbers that are divisible or that are factors of both 6x squared and 2x. So I'm going to do a little thinking here. Luckily, they both have an x in it. So right away, I know I got to take at least an x. An x is going to come out. And then we got to look at the coefficients. 6 and 2. 2 is the largest one we can take. Absolutely. So we're going to take 2 out of both of those.
When
So
you do that, you divide and then the number goes on the outside of the
that's
brackets?
exactly
and
it.
then it's like number bracket, and then it depends on if there's another number on the other.
Absolutely. So this 2x is the first number we now write. And we set up a set of brackets. And within those brackets, it's going to be what these are after they've been divided by the common factor, which is 2x in this case. So we look at the coefficients again. 6 divide 2, well, that gives me a 3. And x squared divide x, that's my power rules. Do you know what that might give us?
It would be x.
It gives us x. So 3x is our first term. And then we also got to do it to our second term. 2x divided by 2x. Oh.
It would just be 1.
It's just 1. Nice and easy. Very good. So we've done the first pair, and now we got to take a look at the second pair. We have negative 3x and negative 1. There's not.
It's not really divisible, but it doesn't really matter because it's not like the second number doesn't have an x and the first number is only 1x.
Yeah. Okay. So what that tells us is we can't take a variable out. I can't take an x out. What about the coefficients? Negative 3, negative 1. They have a common factor.
Both negative.
Both negative, sure, but I need to take a value out with it.
Divided by 1.
Yes. So 1 is a factor of absolutely every single number. So if you ever get stuck and you're forced to take a factor, you can always take 1 out of it. It doesn't change much. Positive 1 doesn't change much. Negative 1 does. Negative 1 will get rid of our symbols. And because they're both negative, this might be the root. So let's do that. Let's say we're going to divide both of these by negative 1. That negative 1 becomes the number in front of the brackets. And then in the brackets, when we divide those terms, what do we get? Negative 3x divide negative 1. Any ideas?
3.
Yeah, 3.
3x.
3x. And negative 1 divide negative 1?
Positive 1.
Positive 1. Now, the way to tell if we've done this correctly is, are these two sets of brackets the same?
Yeah.
They are. If they're the same, then we're good. We can move on from there. If they weren't, that means this didn't really work out. We better go back. We've done some math error. I shouldn't say math error, but we've not carried out the algorithm properly. So technically, the next step is also common factoring again, but it's a little complex to look at just because it looks large.
Yeah.
The shortcut to the answer here is to go, okay, I have a double of one bracket, so that's going to be one of my factored forms. One of the brackets of my factored form, I should say. And then the other bracket here is just both of the coefficients in front of those brackets, which were the 2x and the minus 1. And now I'm in my factor form. I've set this up.
So you always take the one of the sets of the numbers in the brackets and then use the other two to make it?
Yes, exactly. I can show you the actual common factoring, but it gets a little confusing. Really what we're doing, maybe not, maybe it's not, I shouldn't make that assumption, is this 3x plus 1, this is actually a common factor. So I'm actually common factoring out 3x plus 1 and 3x plus 1. So this is becoming the common factor. And then when we would divide these two terms, well, 3x plus 1 divided by 3x plus 1 becomes 1. So 2x is in one bracket and negative 1 is in the other. You don't have to memorize that step. As long as you know the little trick to the end, you're okay. And this was a harder one to factor. Even if we put this one in the quadratic formula, this would have been a little trickier to come up with because these are fractional roots. So the x values are actually fractions, which may have been a little harder if we went quadratic formula to solve it. But let's talk about another style. Same question. No, I don't want to use that color. Y is equal to 6x squared minus x minus 1. The goal here is, do we get the same answer as we're trying to do? So I'm going to scroll down a little. Okay. In this one, I'm going to set up a bit of a different looking chart. I'm going to build some columns. And the reason I'm building columns is I'm looking for factors of the first term and factors of the last term. That's it. So 6. Technically 6x squared. What are some factors of 6? Well, we have 6 and 1. So I'm going to write 6 and 1. And technically there's an x squared, so I'll say 6x and 1x. If I multiply those together, I'll end up with 6x squared. Another set is 3x and 2x. Now, you don't have to write the x's in. It's actually not common, but just want to show you that it can be very precise. We can write those in if we want. I'm going to take them out just for ease of viewing. It's like it's a couple extra symbols. We don't technically have to write them. So I'm going to go 6 and 1 and 2 and 3. Okay? And then the last term, negative 1. Well, it's 1 and 1, and one of them has to be negative. We just don't know which one yet. With that being said, the first ones, I could have two negatives on the first ones. -6 and -1 also equal +6. So just keep that in mind that those are options.
So does it matter, like if you're doing it, does it matter if you choose two negatives or if you just choose two positives?
In the end, when you simplify, you'll end up at the proper answer. But you could start with two negatives. You'll notice here, if you do, it'll tell you if that's wrong or right. You'll be like, oh, actually, that can't be the case in this one. So I'm going to look for a product. The product means I'm going to multiply one of the first two columns. So it depends how many columns there are. There could be 3, 4 columns. This one could have 3 columns. But I'm going to multiply one column by another. Now, luckily, there's only one column at the back here. So I know that those must be two of the numbers. And it's one of these two pairs of columns that we're going to use. When we multiply them, we're going to get some products, which will be over here. And the sums of the products need to be this b value. So -1. I mean, you could write -1x, but we took the x's out of those, so we won't focus on the x, okay? Just the coefficient, -1. So we test a couple. Let's try it. We go 6 times 1, that gives me 6. 1 times 1, that gives me 1. 6 plus 1, not -1. And again, one of these had to be negative. I could have said it was this one or this one. Either way, if it's -1 plus 6, that's going to be 5. And if it's -6 plus 1, that's going to be, -5. Not going to work. So what we've just done is we've exhausted the first column. We know it's not the first column. So we've already figured out the answer. We just got to figure out the order now. 2 times 1 gives me a 2. 3 times 1 gives me a 3. And because these are both 1s, I don't have to try going across either, which we normally would do. Okay. 2 and 3, if I add them together, I don't get it. But remember, one of these has to be negative. If I make the 2 negative, that makes this negative. -2 and 3, that's actually +1. Didn't quite work. If I make this one negative, this becomes -3. -3 and 2, that gives me -1. We've just found it. 2 and 3 and 1 and -1. So now, in this version, I can actually skip right to the end, to the factored form. Y is equal to some bracket times some bracket. I start with the first two terms. There's going to be a 2 and obviously an x. This is where our x comes back. And a 3x. The tricky part here is just which bracket do each of these ones go in, because they're technically different. If I multiply the 2 times the +1, then they don't go in the same bracket. So I got to put that +1 in the other bracket, which means if the 3 was times the -1, it has to go in the opposite bracket. So visually, I took up a lot less space. There was a bit of mental math I played through, but this can be very, very quick method. I don't know what the name of this method is. I don't know if there's a formal name to it. Building columns to factor, whatever it is. This is a very quick method after a lot of practice. It tends to work much faster than decomposition. But the key part is what I wanted to show you, is that we got to the same answer, even though brackets are in different order. It's a law of multiplication. Technically, it doesn't matter the order. But 3x plus 1, 3x plus 1, 2x minus 1, 2x minus 1. Doesn't matter which algorithm you use, you're still able to factor to get there.